Now, here figure 1.1 shows the speed time graph for okay, this is the question from May June 2023 paper 2 May June 2003 paper 2 determinant. Okay, figure 1.1 shows the speed time graph for a car traveling on a straight horizontal road. Describe the motion of the car shown in figure 1.1. Okay, it's a speed time graph. So from this to this point, in the first 10 seconds, we can see that the speed is constant. And if you want to see what is the speed value, so it is 18. And after 10 seconds, the speed is decreasing and decreasing like this. Decrease, it could have, it can decrease like this as well. So it is decreasing rate, it is increasing rate, decreasing at increasing rate or decreasing at decreasing. So this is speed is decreasing at a decreasing rate, and if it is like this, so speed is decreasing at increasing rate. So here you can see that it is decreasing at decreasing rate till 50, and what is the speed here at 50 seconds? So the speed here is 1 to 2.5. So you are required to describe the motion. It's a two-part question. I the values are not necessarily required here. I can write from 0 to 10 seconds. The speed is constant 18 meter per second. From 10 to 50 second, the speed decreases at decreasing rate till it was 2.5, I remember. Yeah, 2.5 meter per second. Now at time t is equals to 10 seconds, the engine of the car is switched off, the brakes are not applied. Name two forces that act on the car to cause the change in motion after 10 seconds. The brakes are not applied. So it can be air resistance, it can be friction between road and tires, air resistance, friction between road and tire. Suggest why figure 1.1 is a curve after 10 seconds. So it's a curve. Curve shows that the acceleration is not constant. Basically, the speed is decreasing. It is not acceleration, it is deceleration, negative gradient. So, but I told you the speed is decreasing at a decreasing rate. It means that the deceleration is decreasing. Whether it is acceleration or deceleration, force is directly proportional to them. If I am saying that acceleration is decreasing, it means the resultant force is also decreasing. If I am saying that the acceleration is increasing, it means the resultant force is also increasing. So right now here we can see that the deceleration is decreasing. It means that the resultant force is also decreasing. So suggest why figure 1.1 is a curve after 10 seconds. So I can write here Resistive force continuously change, making it making resultant force and deceleration variable. Between time t is equals to 10 seconds and t is equals to 20 seconds, the speed of the car changes from 18 to 11 meter per second. The mass of the car is 1200 kilogram. Calculate the change in momentum of the car in this time. Give the unit of your answer. Change in momentum. Change in momentum is basically force multiplied by time. One formula is this. Another formula is mass into final velocity minus mass into initial velocity. So we do not have force. So ignoring first formula, finding change in momentum directly by mv minus mu, I can take mass as common. It will become v minus u. Mass it is given in the question, which is 1200. Final speed at 20 seconds. At 20 seconds, the speed is 11, and at from 10 to 20 at 10 seconds. 10 second the speed was 18. So it will be 11 minus 18. Final speed is 11 minus, and initial speed is 18. So there is no need for other brackets. Okay. 11 minus 18, I guess 7. 7 into 1200. I'm getting 8400 change in momentum. Since the speed is decreasing, though it is obvious that change in momentum will come out to be negative, minus 8400. So minus 8400. Okay. Now the unit momentum is kilogram meter per second. Whether it is changing, it is initial or final, momentum has the unit kilogram meter per second. Calculate the average resultant force. So resultant force is change in momentum divided by time. Change in momentum, I have already calculated 8400. From 10 to 20 seconds, the time is 10 seconds. So I will get 840 Newton here. So this is the simple question. Moving to the next one. Figure 1.1 is the distance time graph for a skydiver who jumps from a balloon at time t is equals to 0. Okay. The first part of the graph shows the motion of the skydiver from when he jumps until he reaches a terminal velocity. It's a distance time graph, remember. Describe the motion of the skydiver from 0 to 20 seconds. From 0 to 20 seconds, we can see here, first of all, you should recall it that it's a distance time graph. The gradient of distance time graph gives us speed. So if the gradient is increasing, it means that the speed is increasing. If the gradient is constant, it means that the speed is also constant. So I can see here that in the starting, the gradient is increasing and then it reaches a constant value because it's a straight line. So if the gradient is constant, it means the speed is constant, but in the starting, the gradient is increasing, which is showing that the speed is also increasing. So speed increases. 1st, then it reaches a constant velocity, which is terminal velocity, and continue to move with it. Explain the motion of the skydiver between 0 and 20 seconds in terms of forces acting on him. So this is the part that it requires some concept, because if in the starting the speed is increasing, it is showing that the acceleration is there. If there is acceleration, there is a force as well. There is a resultant force. So when the skydiver jumps off in the starting, the weight is greater and the air resistance is less. But as it moves down, the upward air resistance increases, because when the speed increases, the air resistance acting also increases. Just a common simple example is this: then that when a car is moving slow and you um, put your hand out of the window, you will feel some amount of force. But if the car has is moving with a higher speed, then your hand will experience a greater force. So as the speed increases, the air resistance is also increased. So here we can see uh, initially weight was larger than air resistance, but as the speed increases, the air resistance also increases, and a time comes when air resistance becomes equal to the weight and balances it. At that time, resultant force becomes zero, and when the resultant force becomes zero, the acceleration becomes zero. Zero acceleration means that the velocity is constant. That's why that constant velocity is known as terminal velocity. Explain the motion of the skydiver between 0 to 20 seconds in terms of forces acting on him. So I will write in the starting, air resistance is less than the weight. As speed increases, air resistance also increases and becomes equal to weight, being opposite in direction. It makes resultant force equal to 0. Using figure 1.1, determine the terminal velocity of the skydiver. On figure 1.1, indicate any value used for your calculation. Terminal velocity is the constant velocity. The whole part where the line is straight is the terminal velocity. So what you are required to find the gradient of this graph, because the gradient gives us the speed. Distance time graphs gradient gives us speed. So we have to mention the points only. What points I am taking here? I am taking one point, which is first of all, put up a scale and see. Oh, it's getting hanged. Till here it is, so I can take one point as 15. So at 15, the speed is 500. 15 comma 500. and at 50 the speed is 2200. So 50 comma 200, 2200, sorry. So it will be 5, so 2200 minus 500. You have to mention the values on the graph. So 2200, first of all, I will write velocity is equals to gradient delta y over delta x. So 2200 minus what was the value? It was 500 and time is 50 minus 15. 48.57. So it will be 49 meter per second. Okay, this is the question from vector. So okay, leave this question here. This is from May, June 2021. I'm not doing vectors right now. For vectors, I will make a separate video. Okay, this question is from 2021, October, November, paper 2, variant 1. Figure 2.1 shows a man of mass 80 kg is standing in a lift. Okay. The gravitational field strength is 10 newtons per kg. Calculate the weight of the man. So we know weight is W is equals to mg. Mass times gravity. Mass is 80. Gravity is 10. It is 800. So 800 Newton. The lift accelerates upwards uniformly at 0.50. Calculate the resultant force. So force is equals to mass times acceleration. Mass is 80. Acceleration is 0.50. You will get 40 newtons. The force exerted on the man by the floor of the lift. Okay. So this is the downward weight. This is the upward force by the floor. And the resultant force that we have calculated, it is 40. So as the lift is moving, as lift is accelerating upward, it means upward force is greater. So resultant force is the when the forces are opposite, we find the resultant force by subtracting both the forces. But here, while subtracting, we will see the direction of motion, and we subtract the greater force, a smaller force from the greater one. So here, if the acceleration is in upward direction, the lift is going upward. It means upward force is greater. So resultant force will be upward force minus weight. So resultant force is upward force minus weight. So if I want the force, so resultant force plus weight will become equal to this. So resultant force was 40 and this was 80. So 80 plus 40 will give us 120 Newton. Okay. The lift accelerates upward uniformly from rest for 4 seconds and then you decelerates uniformly to rest in 4.0 seconds. The total distance traveled is 8.0 meter. On figure 2.2, sketch the distance time graph. Okay, remember, when we are saying it is accelerating, it means that the speed is increasing. If we are saying that it is decelerating, it means that the speed is decreasing. Now, here the graph is distance time. The gradient of distance time graph gives us a speed. I've already mentioned so many times. If I want to mention that the speed is increasing, I have to make a increasing gradient graph. If I want to mention that the speed is decreasing, I have to draw a graph with a decreasing gradient. So the lift accelerates upward, shows the speed is increases from rest to 4 second, and in the other 4 second decelerates uniformly, and the total distance traveled is 8 meter. So first of all, so increasing distance time, increasing speed is like this and decreasing speed is like this. Remember this thing. So at 4 second, as it is speeding up, graph gradient is increasing, and when it speeds down, the gradient gets decreased. So this is the graph here. Okay, this is the question from 2021, October, November, paper 2, variant 2. State what is meant by a vector quantity. A vector quantity is one which has magnitude as well as direction. Vector quantity has both magnitude as well as direction. Okay. Uh, a swimmer reaches the end wall of a swimming pool and turns around under the water. Figure 2.1 shows the swimmer immediately after turning around. The swimmer pushes against the end wall of the pool with his legs. Explain in terms of Newton's third law why the swimmer accelerates away from the end wall. So, Newton's third law, to every action there is an equal and opposite reaction. The swimmer pushes the wall with some speed, with some force F. The wall exerts equal and opposite force to the swimmer, and this force will cause the swimmer to accelerate. Swimmer exert force on the wall. The wall exerts equal and opposite force on the swimmer, which accelerates him away in opposite direction. Okay, while swimming, there is a constant forward force on the swimmer. His speed increases until eventually he reaches a constant speed. Explain why he reaches a constant speed. So when the swimmer is continuously applying force, So in the starting, the speed of the swimmer is less, so the resistive force by the water is less. But as the swimmer's speed increases, the resistive force also increases, and after some time, it becomes equal to the force applied by the swimmer. When the force applied by the swimmer and the resistive force becomes equal and opposite, the forces balance each other and the swimmer starts to move with a constant speed because the resultant force becomes zero. So there is no acceleration. When there is no resultant force, there is no acceleration. When there is no acceleration, it means there is no change in velocity. So why he reaches a constant speed in starting, resistive force is less than the force applied by the swimmer. As his speed increases, resistive force becomes equal to force applied by him. Resultant force and acceleration becomes zero. Okay. Next question is from May-June 2021, paper 2, variant 2. So here, a car approaches a set of traffic lights. The lights change to red at time t is equals to 0. Figure 2.1 shows how the speed of the car changes with time. The car starts to slow down a short time after the lights change to red. Determine the time between the lights changing to red and the car starting to slow down. So at time 0, the lights change to red, but car starts to slow down from this point, and this is the time which is 1.4 1.4 seconds. It took 1.4 seconds to slow down. What is meant by uniform acceleration? Acceleration is change in velocity per unit time. If in equal amount of time, if I observe the change in velocity, if change in velocity is same after each interval, so the value of acceleration will also be same. So I will write equal change in velocity in equal amount of time. State how figure 2.1 shows that the deceleration of the car between 2 seconds to 7 seconds is non-uniform. Okay, it's a speed time graph. The gradient of a speed time graph gives us acceleration or deceleration. If the gradient is constant, then acceleration or deceleration is constant. If the gradient is changing, it means that the acceleration is changing. You can see that from this point to this point, and from this point to this point, gradient is changing. The change in gradient is showing that the deceleration is not uniform. So that's what they are asking. Shows that how figure shows that the deceleration of the car between this and this is non-uniform. The gradient is changing. Determine the distance the car travels from the moment the car starts to slow down until it stops. Again, determine the distance the car travels from the moment the car starts to slow down until it stops. So the whole shape we need to find, because it's a speed time graph, we are required to find the distance. So we are required to find the area under the graph. So first of all, I'm writing distance is equal to area under the graph. We have to break it down. It's a rectangle here. It's a triangle at the right. It's a trapezium in between. I can break it down for you, but there will be so much shapes. Four shapes. Already we are in three shapes. One, two, three. So this is the rectangle 20 and this is time 1.2. No, 1.4. So 1.4 into 20 plus this is a trapezium. One side of the trapezium is 20 and the one side is 8. Trapezium, if this is the trapezium, this is known as A, this is known as B, and the distance between them is called H. So the area is half A plus B into H. So half A here is 20, B is 8, and H is from 1.2 to 4. 1.2, no, 1.4 to 4 is zero point 0.6, 2.6, I guess. Yeah, 2.6. So I'm writing it here as well. 1 upon 2, 20 plus 8. 1 upon 2, 20 plus 8 into 2.6 plus, again, now this is a triangle. So this is 8. This is 4 to 7, which is 3. So 1 upon 2, 3, and 2.6. It was, no, it is 8, sorry. So if I calculate them all, 1.4 into 1.4 into 20, it is 28 plus 20 plus 8 is 28 into 2.6 divided by 2, 36.4, and it is 12. 12 plus 36.4 plus 28, 76.4. So I will write 76 meter here. Okay,